things like, for example, the complexity of the model, for example, choosing the amount of layers and neurons of a neural network, choosing the learning rate, how fast the model learns, or is the weights are adjusted, or how we prevent overfitting, are very distinct from the internal parameters of the model. This is what the model actually learns. And as there are not things the model learns from the data, we have to provide them somehow. For example, regularization. So, for example, we run one experiment, let's say experiment A, and we have like a predetermined set of parameters. Then we say, okay, what about if we change the learning rate and make it train faster? What happens? Let's try. So then we run experiment B, and then we try something else, and we end up with experiment C, and with another like set of parameters. Each of these experiments, of course, to solve the task we are trying to solve, have different performance. Let's say they train differently. So we can say, for example, the training A trains all right, but maybe overfits. Well, this is the result. Experiment C, for example, that overfits too much to the training data, and the validation in the validation data, it starts the performance to go bad, let's say. But for example, if the learning rate is not, let's say, if it's very slow, let's say, the model can like last more time into like convergence and take more time, or more epochs, let's say. So it's not easy to choose a good set of parameters or find them, let's say. So the issue with finding good parameters and also be well organized with the experiments. This is not just a personal organization problem. We want to, for example, say, okay, I want to try on this model on this data, and then change to this another model on maybe data change, because it can be data that changes over time, and we want to try new regularizers or new techniques. How do we organize ourselves? There was a group of people of researchers on Google that wrote this paper in 2015 called Hidden Technical Debt, that showed that machine learning code is just a very tiny black box in the middle of a much larger set of other components, infrastructure components like data, feature extraction, how do we serve the models, how we monitor the models, how we configure them. So even if the machine learning model is solid and can solve the task itself, neglecting these other components that are not part of this tiny black box creates enormous technical debt. So that can make the systems more fragile or very hard to maintain. Also, when we experiment, we try new models. We may create many Jupyter notebooks, and we all know Jupyter notebooks are not production systems. We need to move from this world of research or just testing how everything looks, let's say, from a very restrained framework to a more tracked and managed system. And this is what then turns them all into a more reliable software component.